try this problem here. In other words, this means the cube root of 0.07. And the way I'm going to get that on the Inspire, there's actually two ways to get it. They're the same key, but the primary key is this key right here. You know where that's at?
1 second, sorry. It's asking me for my email.
Oh, okay. Okay. Tell me when you're... Oh, on GoToMeeting, probably.
Yeah.
Yeah, I noticed. There you go. That's the first time your name showed up. Ah, interesting. So it lets you into the meeting without an email, but keeps bugging you about it, apparently. I had never seen that happen before. Okay. Can you hear me now? Okay.
Yeah, all good.
So you see where that key is, the arrow key?
Yeah.
So type in, go to the calculate section. Type in 0.07 and hit that arrow key. You see what happens? Now you can put a fraction in the exponent. You can type 1 divided by 3. Go ahead and do that.
1 divided by 3?
Yeah, and notice that the entire exponent is 1 divided by 3, is it not?
No, it gave me something weird. 0.07 and the arrow. Okay, I got it now.
What do you get for an answer?
0.412129.
Correct. Correct. Okay, so that's how you take cube roots. Now, if I was taking the square root of 0.07, I would take 0.07, and there's a couple of ways you can do square roots. You can raise it to the 1/2, you can raise it to the 0.5, or you have a special key above. You see where the x squared key is?
Yeah.
Right next to the arrow? If you hit that, that will square 0.07. But if you hit the blue key of that key, it will take the square. It'll take the square root. But to me, it's almost easier to just use this arrow every time you're trying to raise any number to an exponent.
Okay.
Okay. And given the material that you are covering, linear ratios, area ratios, and volume ratios, right?
Yeah.
Well, area ratios are linear ratios squared. Volume ratios are linear ratios cubed. So, whenever they give you one of these, you can always figure out the other two. In other words, if I give you an area ratio of 36 to 9, what's the linear ratio?
2.
Correct. The square root of that. What's the volume ratio?
8.
Correct. In other words, pretty much for every single one of these problems that you're getting, if you did this as your first step, then you would, the rest of the problem is easy. Now, you don't always need the volume ratio, but you always need the linear ratio. Because sometimes they'll give you the area ratio and they'll ask you about the volume ratio. What do you have to do? You have to go back and first figure out the linear ratio and then cube it to get the volume ratio. So there's no avoiding figuring out R sub L. Now,
Okay.
if they give you one of these two and ask about the other one, well, then you don't really need that one, but know how to get the volume ratio, even if they don't ask you about it. I'm tempted to tell everybody that start every problem that's about these ratios off in this manner. Now, notice the problem I gave you. I could have first simplified that to the number 4 and taken the square root of 4. Or I could do it maybe the way you did it, which was to take the square root of 36, take the square root of 9, and that is the same as 2. Either way, so you can take these ratios and convert them to numbers or decimals. Now, I've been working with a lot of geometry students from Chatfield. And I'm gathering that it really is okay if you do big to small. You don't have to do everything in small to big.
All right.
Okay? And that will make things easier because that always ends up being a number greater than 1. And when you do stuff like take square roots of it, they make sense. Whereas if you do small to big, you end up with numbers like 0.07, and when you take the square root of 0.07, it gets bigger, oddly enough. So I'm a big proponent of doing big to small always. You'll get the same answer either way, but the most important thing to never do is mix them up. You can't do a problem and start off doing big to small, and then in the middle of it, switch to small to big. You'll get the wrong answer. Now, did you send me some problems? Yeah.
I sent you. Yeah, I sent you some.
Yeah, here, let me pull it up real quickly. This actually looks like something new, which is surprising because a lot of times I'll get like 5 copies of the same set of problems all sent to me. Oh, I think I do have this one. No, maybe not. Let's take a look. Where would you like to start?
Scroll down towards the more. Yeah, those kinds of ones where we actually have to apply it. Yeah.
So, the first thing we need to do is to be able to figure out what the total sum of the angles is based on how many sides there are. What's the formula for that? It's something times 180.
This one would be 8 times 180?
No, it's the number of sides minus 2.
Oh, okay.
No matter how many sides. This
Right.
one is 8-sided, so it's 6 times 180. What's that?
Uh, 1080 or 1080.
And this angle right here is going to be what? 1/8 of that, right?
Yeah.
So I'm going to take that answer, the sum of the angles, and divide it by the number of angles that are in there. Because this is a regular polygon, all of these angles are equal. So I can do that. Okay? And what do you get for that? So each of those angles is what?
Um.
35?
Yeah.
Okay. And now what? They want us to actually solve for x here. They're not asking us directly what that angle is. So what do I have to do to solve for x?
Divided by 4, or subtract 21 and divide it by 4.
There you go. First of all, you want to set it equal to 135.
Yeah.
That's kind of what I was getting at. Okay?
Okay.
Once you do that, then it's a simple algebra problem.
Okay.
Okay? And if you want to go through that algebra, I'm happy to. If you feel more comfortable coming up with the answer. But we can cover more if we don't do the arithmetic stuff. Although for this one, that's 156. And x would be 39.
All right. Yeah, I have that stuff pretty well done.
Okay, good. 41. What kind of figure is this?
For 41, it's a quadrilateral.
It is a quadrilateral, but it's a special kind of quadrilateral. What kind? What's it look like? Put a tail on it.
Okay.
A kite, yeah. It's a kite. It's one of the few symbols that looks exactly, well, not really. Diamonds look like diamonds. But if it looks like a kite, it's probably a kite. And notice what a kite has are these two sides are the same, and these two sides are the same. But that's it. They're not equal to one another. So it's not a rhombus that has four equal sides. But it does have two small sides that are same and two those sides. And what else is true about this kite in terms of, notice that what they're asking about is angles, right?
Mm-hmm.
So what do you know about the angles of a kite? And you can almost know this by looking at it. There's a kite. What's true about the angles?
Well, two of the sets of angles are shared.
Well, hold on. Look at that kite I just drew.
All right.
What would you say about the angles? Are any equal to one another?
B and D are equal.
Always. Are A and C equal?
No.
Okay. So it's only one set of angles that are equal.
Okay.
However, so in this picture that they've drawn, that's 4x minus 9. And I find it unusual that they didn't put degrees there, because usually they do. In other words, that's one of the clues for determining whether they're talking about side lengths or angles. Now, this one is clearly an angle, but it's not always as clear. What's D? In other words, they got 3 of the 4 angles labeled. Can I label D?
D is just 4x minus 9.
Now, what equation can I write in order to solve for x? Always be looking for that equation. What do I know about the sum of those 4 angles?
They equal 360 degrees.
So, what's the equation that I want to write?
15x minus 1 second.
Yeah, you don't have to do all that in your head. Mainly what I was looking for from you is this. 5x plus 11 plus 4x minus 9 plus 2x minus 8 plus 4x minus 9 equals 360. There's the equation. Now,
Okay.
I'm expecting that you know how to simplify that.
Yeah.
And solve it. You know, that's... algebra. Not that I haven't had my share of geometry students that were a little not remembering algebra from last year. So by all means, if you ever have any questions about the algebra, tell me about them, because it's absolutely necessary that you be able to do this kind of algebra to succeed at geometry. You know, half of geometry is algebra, really. Don't you agree?
Mm-hmm.
Okay. And 42.
Mm-hmm.
What is true about line AC? With regards to the larger triangle.
Is it parallel to ED?
Correct. Only because AC bisects both of these sides. It bisects EB into two equal pieces, and it bisects DB into two equal pieces. And the only way it can do that is if it's parallel to ED.
Okay.
So, what does that make in the way of similar triangles? Do we have any similar triangles here?
ABC is similar to BDE.
Okay, good. So what I have found helpful is when you're looking at these kind of problems, I really, in my mind, I've always found it to be quite helpful if I actually separate the triangle. You don't always need to do that, and it may not help you as much as it helps me. But there's my two triangles. Okay, this is D, E, B, and this is A, B, C. And they're similar. And let's start labeling. That's 15. What's EB? Dimensions.
EB is just EA plus 15.
What's EA? Based on the
15.
There you go. So EB is
30 centimeters.
So what is my similarity ratio between these two triangles?
15 to 14.
Always make sure you're measuring similar sides. In other words, I've got enough information on this thing. I know that angle D is the same as angle C in my similar triangles. And I know that angle E is the same as angle A, and B is the same as itself. So if I want to find the corresponding side that is similar to AB, look for the side that's opposite the angle that's the same as D. That'd be 30. So if I'm looking for a similarity ratio, I've got to compare the corresponding sides of the similar triangles. And like I said, I much prefer doing 30 to 15, which gives you a 2 to 1 similarity ratio. Is similarity ratio a term that your teacher uses?
We just usually say ratio. We don't talk about similarity.
Or he calls it linear ratio, maybe? Because notice, with triangles, the linear ratio is not the same as the area ratio. The area ratio is the square of the linear ratio. So in all, he should be calling this R sub L, like that. But I've heard it called similarity ratio by other teachers, and I like that. Because once you've discovered that the similarity ratio is 2 to 1, big to small, then finding the sizes of other things becomes a piece of cake. In other words, what is CB, the dimension of CB?
14 centimeters.
And DB?
28.
And this is 4x minus 8. What is this one over here?
Which one?
What's AC?
AC, isn't it the...
Well, we have a, what's this? If the similarity ratio big to small is 2 to 1, then what is AC in terms of x?
2x minus 4.
Good. Now, it tells us that the perimeter of the little one is 39. What's that make the perimeter of the big one?
678.
Correct. Okay, so I know its perimeter is 78. How can I solve for x? Give me the equation that I need. And don't do any of the steps. Give me the raw equation. Don't simplify.
Alright,
Because it's important to see that. And I want to make sure that you're seeing how you're going to get this equation.
For just all day.
I have two choices, actually. This one perimeter is 39. Either one of these will allow me to solve for x. Well, let's use the smaller numbers.
Okay.
What's the equation?
So, 2x minus 8 plus 15.
2x minus 4.
Yeah, sorry. 2x minus 4 plus 15 centimeters plus 14 centimeters.
Equals?
39.
Okay. That's always what you want to do as the first step. And I really kind of highly recommend that you don't try to take shortcuts. That you always write this out and then simplify it. Don't, as you're doing it, don't try to add those three, combine those three numbers together in your head. That's just, that to me is a recipe for making errors for anybody. Okay, what do we know? What kind of figure is 43?
Just a rectangle.
No, rectangles have to have 90-degree angles.
Parallelogram?
Correct. Opposite sides are parallel. What do we know about these two angles? This one and this one. Well, first of all, what do we know about this angle and its opposite angle?
They're equal.
And this angle and this angle?
Equal.
And adjacent angles, what do we know?
Equal 180.
They're supplementary, correct. So my equation is going to be
5x plus 20, or 7 and 8x plus 20 equals 180.
I really like the way you started it better. 5x plus 20 plus 3x equals 180. In other words, yeah. And then you did the shortcut combining them, which is okay when you have numbers like this, but in general, that's a recipe for making mistakes. Okay, this perimeter what's this angle right here, 44?
75 degrees.
What's that? What kind of triangle is that? If that's 70, right. Which makes what? What equation can you write? If that's an isosceles triangle, and we know at some point we're going to have to solve for x, So let's write an equation that involves x that we can solve for.
Okay.
What would it be? What's true about isosceles triangles?
Their base angles are equal.
They have two equal sides. They are the sides opposite the equal angles. So this side's equal to that side. So what's my equation?
4x minus 11 equals 2x plus 9.
Okay, that's going to allow you to solve for x, right?
Yeah.
Because there's only one variable. Then they want the perimeter. So once I have x, now you can say what? 4x minus 11 plus
2x plus 9
plus
8 plus x is equal to...
And that, once you have a value for x, that will turn into a number, and that will be your perimeter.
Okay.
Okay? All right. Well, it's almost 5. Are any of these questions? Do you have any questions about them?
Nope.
These are a little bit strange. A rectangle is or is not a parallelogram?
Is.
A rhombus is or is not a parallelogram?
Is not.
No, it is. It turns out that it is. In other words, a rhombus is 4 equal sides. Well, you can't draw 4 equal sides without making it a parallelogram. In other words, try doing it, you can't do it. In other words, if I tried to draw 4 equal sides, something like that side's not going to be equal. So when you do 4 equal sides, it is a parallelogram.
Okay.
What about a square? Is or is not?
It is.
I assume that's what they're looking for here. Is that correct?
I think so.
Oh no, we're supposed to take the choice from these and fill it in? Yeah, there's 16 of them there, and there's 16 blanks. Oh, I see. So what could these possibly be? A rectangle is an... What answer fits there? I don't even see... Oh, a perpendicular parallelogram. So actually what went here was the word perpendicular. All right.
Okay.
I'll let you do those. You can probably figure out those pretty good.
All right.
Mark, have a good rest of your week, and I'll talk to you on Thursday.
All right. Thank you, David.
You're